Hey everyone, welcome back. Today we are talking about an absolutely essential topic in programming, especially in languages like C++, the heap in memory management. Let's dive straight in. First, let's quickly define what the heap is. In computer science, the heap is a region of a program's memory where dynamic memory allocation takes place. This memory is managed by the operating system and is used when you don't know ahead of time how much memory you will need. In contrast, we also have something called the stack. The stack is fast and automatically manages memory, but it's limited. When you need more flexible, longer-lived memory, you use the heap. In C++, when you allocate memory on the heap, you usually use the new keyword. In this code, we dynamically allocate an integer on the heap. The new keyword asks the operating system for enough memory to hold an integer and returns a pointer to that memory. The important thing to remember is that memory you allocate with new stays allocated until you explicitly free it. If you forget to free it, you create a memory leak. Memory leaks are dangerous because they can make your program consume more and more memory over time, possibly crashing your system. To free heap memory, you use the delete keyword, like this. This releases the memory so that it can be reused. Now, if you allocate an array on the heap, you use a slightly different syntax. Here is an example. This creates an array of 10 integers on the heap. And when you are done with it, you need to free it using delete square brackets instead of just delete. If you forget the square brackets, you might not properly free the entire array, which would cause undefined behavior. Now, you might be wondering, why not just use the stack all the time? The answer is limits. Stack memory is very limited, usually just a few megabytes. Heap memory is much larger, potentially gigabytes, and can handle much bigger dynamic data structures like large arrays, linked lists, trees, and so on. But heap memory is slower to allocate and deallocate because it requires system calls under the hood. Also, you have to manually manage it, which can introduce bugs. In modern C++, we often avoid row new and delete by using smart pointers like std_unique pointer and std_shared pointer, which automatically manage heap memory for us. Here is a simple example with std_unique pointer. When the unique pointer goes out of scope, it automatically deletes the memory it owns. This helps prevent memory leaks. Another thing to keep in mind is fragmentation. As you allocate and deallocate different sized blocks on the heap, it can become fragmented over time. Fragmentation means you have free memory, but it's spread out in little pieces instead of in one big continuous block. This can make it hard to find a big enough block for a large allocation, even though enough memory technically exists. Some systems use heap managers or garbage collectors to help deal with fragmentation and leaks, but in C++ you are responsible for it. Let's quickly review. Heap memory is dynamic. You use new to allocate and delete to deallocate. If you forget delete, you leak memory. Arrays need new square brackets and delete square brackets. Use smart pointers in modern C++ to make life easier. And that's a basic introduction to the heap in memory management. Understanding how the heap works will make you a much better programmer and will help you write faster, safer, and more efficient C++ code. Thanks for watching and see you on the next video.